Just before I start, wanted to get an idea here. How many people have virtualization in their environment currently? Some? Some? Okay. How many don't have virtualization at all? Few? Okay. Any plans to do virtualization? Anyone? Okay. So I've kept this kind of generic, no particular hypervisor or anything. So if anybody has any questions, we'll have those at the end. So let me start with who am I? My name is George Pastino. I've been working for Clear for a little over 2 years. I've been in IT my entire life. I've done coding since I was age 9 with BASIC on my Candy Color Computer 3. I've held many IT-related roles over 20 years. I've done help desk, network admin, email admin, network engineer, and most recently virtualization engineer. I have a BCP in data center virtualization, along with other industry certifications, Microsoft Citrix, that kind of stuff. And so let's start with what is virtualization? Method of consolidating servers to allow you to use hardware to its greatest potential. Well, what does that mean? The average server you purchase, you use about 1 to 3% of its total capacity. And the problem with that is you're leaving a lot on the table. It's not a really efficient way of doing it, and then you have to buy multiple servers. It just becomes kind of something that runs out of control. You have to cool it, you have to power it, etc. So virtualization's been around for about 20 years, believe it or not. It's more recent of a thing. And so we basically consider it subleasing of a server. So like I said, 1 to 3% on average. So we're basically stacking a bunch of different operating systems or similar operating systems on the same piece of hardware. They're all isolated from each other. So instead of having just a small business server is a popular one with Microsoft, where they'll have Exchange, they'll have SQL, they'll have file and print services, all in one box. It doesn't do any one of those particularly well, so we're able to spread them apart, give them enough hardware to operate, and you have a pretty good platform to work with. Like I said, it allows several servers to share resources. Servers are isolated. The cool part about that is the servers are isolated from each other insofar as they don't know that they're sharing hardware with other machines, which is kind of important for that to work. Let's start with the first thing here, hypervisor. It's a word that not many people understand what it's about. It's the software you have on the server itself. You basically load it onto bare metal. That's, there's a couple different ones. There's ESXi from VMware, Microsoft Hyper-V, which is what some people may have started with here, and Citrix Zen Server. The host is the only physical piece of hardware we're talking about here. It's the server. It's the bare metal server that you purchase from Dell or Microsoft or whomever. That's usually what you load your hypervisor onto. And it's, like I said, the only tangible thing with it. Everything else, when we're talking virtual servers, we're just talking simply software loaded up onto the hypervisor. And then, along with the word virtualization, we hear this a lot, cloud. You hear about it on the radio, on TV, people talk about it. Well, what is it? It's other people's computers. It's instead of you having to go buy software, or rather hardware, you contract with another vendor, and they'll actually have all the hardware in place. They'll have the servers, they'll have the SAN, they'll have all the network infrastructure in place. That allows you to, instead of having to go and buy and build all the stuff yourself, you simply give them your data. And that's where they run it, on their infrastructure. So it saves a lot of engineering time, a lot of concerns about things like, what if your power goes out? Well, you have to have a generator, but before that you have to have a UPS. And the cost spirals out of control pretty quickly if you're not careful with it. And more to the point, when we're talking cloud technologies, it runs, somewhere within the infrastructure. The where is not as important. It runs somewhere within an infrastructure of dozens or even hundreds of servers. Could be thousands potentially. And why it doesn't matter is because as long as you're able to access your resources, which you can through the network, where it runs is not terribly relevant. So location does not need to be precise. It could be, this, one particular rack in 1 minute, and then move it to another server with the same rack, same row of racks, same building, another building in fact. And it's all while you're using it. That's the cool part. If you have a server that, your file server, and it's in the cloud, and they're having a problem with that particular host, they could actually move it from one host to another without your knowledge, which isn't necessarily a bad thing. That's how this stuff operates. The decision to move it to another piece of hardware is usually for reasons like there's an excessive amount of latency in the system. You may not even detect it yet, but the system does. Or there's somebody who's actually actively monitoring it, a human that's looking at it. They see something on the console they don't like. They're able to shift servers off to another host to kind of get the response times back down. The potentially without your knowledge thing, that's actually a good thing. You don't want to notice. If you notice, that means you have to power it down. Everybody here suffered through outages before. Could be a minute, could be an hour, could be day or days. It's a tough thing. You want to be up as much as you possibly can be, day or night. A lot of people are thinking, well, after hours. Well, we receive emails all the time. We all have smartphones. If Exchange servers and whatnot ran forever, we'd be in great shape. But sometimes they require maintenance or so some of the pros of virtualization. Allows for redundancy. What I mean by that is, let's say if you do it in-house, you can purchase multiple pieces of hardware, and then you can actually load your operating systems on there. So you'll have your file server, you'll have your domain controller, Exchange server, SQL server, even a web server if you so desire. Doesn't really matter. You have the ability to move it across multiple pieces of hardware, again, with it still running. So if you have to do a maintenance cycle on a particular piece of hardware, you get a bad hard drive or something. Some people get concerned about if you have a bad hard drive that the server's going to have to come down. You can simply move it over to another box. You could what they call vMotion in VMware, a vMotion operation, and go ahead and move it over to another server. Also, if it were to fail, which happens with servers sometimes, even the best ones, even the best built ones will fail. If they fail, the system can automatically move, not necessarily move so much as it will pick the VMs that have crashed and move them to another host and power them back on. It's the equivalent of kicking the cord out of the wall on a server. So you'll be up and running usually within a few minutes at that point, versus having a dead piece of hardware that you have to go and call Dell or HP support. And even if you have a 4-hour support window, you're down for 4 hours. We're talking 30 seconds to a minute, perhaps less, depending on how fast your storage is. So reduce your hardware budget. One server, one operating system, one piece of hardware. That's the way it was typically run for years and years. I can do 10 plus servers onto one server. The consolidation ratio is typically 3 to 4 servers per core. And if people aren't familiar with CPUs, traditionally we had a server with multiple CPUs. It'd have physical CPU, physical CPU, physical CPU, physical CPU. It gets expensive, it gets power hungry. Newer servers use cores. All that means is we've taken the functions of that processor, shrunk it down, and then we put multiple cores into a single processor. So if we talk about a dual processor box that has 8 cores, it's in fact similar to an older box that has 16 processors in it, which is kind of nice because you can throw a lot more compute cycles at a server, which means it runs a lot quicker. Reduces utility and cooling needs. To cool off 3 servers is a lot cheaper than cooling off 10 servers. Some people put their stuff in a closet or something, and they'll put a fan up top or something. You do that with 10 servers, it's going to be like opening a dryer every time you open the door, and the hardware doesn't run great when it's hot. They work very hard to keep these things cool, and they'll generate anywhere between 4,000 and 7,000 BTUs per server, so it adds up quickly. I mean, your average house system is 100,000 BTUs, and that only goes on for a few minutes at a clip. So just think to yourself, 70,000 BTUs running for 24 hours a day, it's going to get warm, and that's when parts start breaking down. And then fewer moving parts to maintain. If I have 10 servers, that's maintenance on 10 servers. If I have 3 servers, which is the usual recommendation for when we're talking like a virtualized cluster, you could have 2, but usually with n+1. You'll have 2 servers, and the third one is there in case you lose one of the other 2. So 3 servers, cheaper than 10. Simple math. There are some cons. It's complex to implement correctly. They go to great lengths to make it sound simple, and it can be in concept. There's a lot of little switches and knobs that you could turn to make it run better or potentially worse if you don't know which those particular switches or knobs do. Incorrect implementation can lead to downtime, data loss, overspending. Nobody wants to have to deal with any of those things. So there's 3 aspects of virtualization we're talking about here. Processing, storage, and networking. First one, processing. It's where your guest is being run. So on a physical server, you assign it X amount of CPUs. I'm going to give, it's a file server, so I'll give it 2 virtual CPUs and why not 8 gigs of RAM. And that's where you've assigned to it on a box that probably has 2 CPUs, 8 cores per with 128 gigs of RAM. So you've set that aside for this one particular VM. And we use the traffic cop analogy because that's what the hypervisor is there for. It basically runs between the various VM guests and between that and the hardware itself. So it's responsible for taking care of making sure each of those guests gets its CPU time or its RAM allocated or disk or network. It actually does all of these things. It prioritizes and routes CPU requests and RAM allocations for the entire physical server. So if I've got 30 VMs, which is not uncommon, that's actually a pretty low ratio in terms of that. The hypervisor is responsible for making sure all 30 of those machines get their access to the hardware as they need it. So it's doing quite a bit, and it does even more than this. Second part, storage. It's where your data resides. It's a hard drive, except it's not just a hard drive. It's usually a bundle of hard drives. It could be 6, 12, 24, hundreds, thousands of drives together. Typically in a SAN or a NAS. The terms used somewhat interchangeably. There are subtle differences between the two of them. The hypervisor runs between the guests and the SAN in this case, through the hardware, and pulls the data that it requires. So if it's asking for a particular block of disk, you're going to go open a file on your workstation. So it goes out to the server, tells the virtual guest, hey, this person's requesting this file. That goes out to what it thinks is hardware, which is actually the hypervisor drivers. That goes to the hardware, out to the SAN collects the data, brings it back to you. And this happens within, we're talking milliseconds here. So it's pretty much imperceivable, except for when your SAN starts to get saturated, which depending on the vendor, depending on what you're asking for from it, it can get pretty unpleasant to use. Your servers, and the problem is when we're talking about virtualized environments, if you have one particular box that's running amok, it can negatively affect all the other guests on that particular host. If it's chewing up CPU cycles a lot, but that's why we only give it a portion. We only give it 2 CPUs. Can you go and build the box and tell it, I'm going to give it 16 vCPUs for every single host every single guest on this? You can do that. You probably won't like the result. The first time you do something like install Windows patches, we all patch workstations. The worst ones of all are usually .NET patches. Those take the most CPU. I watch it happen all the time on my servers. I'll go and run my .NET patches, and it will eat the entire set of CPUs, 4, 8, 12, 16 CPUs, 100% for 10 or 15 minutes. Now, if I have other stuff on that particular VM host, they're going to be feeling that too, which is why we do patches at night. That being said, if you're bringing up a new server and you're not cognizant of this, it can negatively impact it. So let's move on to networking. It's how your server and endpoint communicate. You have a set of, say, 4 gigabit network cards in a server. And I've got, again, 30 guests on here. Well, how am I going to get 30 guests to go out 4 network cards? There's our friend the hypervisor again. And it's taking all that data from your guests out to the physical network card, and then it follows its typical route on the network. One of the things that's interesting to mention about virtualization, if I have a guest or a VM host and I have 30 guests on it, maybe I'll have a SQL database on a front end. Now, typically, if you run those on separate servers, they'd be connected over a gigabit connection or a 10 gig connection. When you have 2 virtual guests on the same host, the communications between those 2 guests is as fast as the motherboard will allow, which is typically in excess of 10 gigabit, could be 40 gigabit. It's literally as fast as the chipset can make it happen, which is incredibly fast because we're talking about a distance of mere inches. We're not having to go out various connectors onto a cable out to a switch. So when we're talking about stuff like that, operations magically just seem faster. And it's because it's running through the hypervisor instead of actually going out to the physical hardware, hitting a switch, finding the other port, going up to the other server. So it shortens that time. So if you have a SQL, like I said, SQL and then a web front end, and you're running queries against it or you're inputting data, it can respond quicker than if it was on two separate physical servers. We talked about earlier about clouds. Well, there's three types of clouds. You got public, private, and hybrid. First off, the public. Public cloud. Guests run the cloud over a provider. So basically what this means is you can go to a provider and they'll spin you up a box. It could be a Windows server or Linux server or whatever they happen to support. And you get your data out there. You can use FTP or other various methods. And it's their hardware, it's their network connectivity, and you just connect to it through the internet. Now you can do a VPN tunnel, or preferably MPLS if you do it right, because there's no VPN, there's no access control rules, there's no, well, it passes through the firewall, but it happens to drop this one particular UDP packet that's crucial for this server to receive, otherwise nothing works right. So little gotchas like that with VPNs. You're sharing resources with other tenants. So like I said, I have a box here, it has 50 VMs. That could be from 50 different clients or 2 different clients, it's hard to say. You can't see them, they can't see you. It all operates within the construct of the actual physical hardware, and the hypervisor divides all these things. If you have multiple servers on there, can they talk to each other? Sure. We set that up in the hypervisor to allow them to talk to each other so that they're able to actually do what you're expecting them to do. It is now the most common way that people run virtualized environments. There's still something to be said for private environments, but a lot of people, they don't want to deal with the complexities or the nuances of dealing with virtualization, so they shove it out to the public cloud. It's got pros and cons. Advantages, typically the lowest cost. You don't have to buy hardware. You're not buying the SAN. You're not buying, a UPS or a generator to keep the stuff running, because you typically do want it to run all the time. No on-prem equipment to operate. The public cloud is actually very secure and very private, and we do that by isolating the VMs from each other, except if they're yours, obviously. There's no way to go from, say, your VM space to somebody else's VM space. The hypervisor has a lot of security built into it to prevent such a thing from happening. Any sort of breaches are usually from the network perspective, and that's if you don't have a firewall properly set up or you have weak credentials on a user account. Everybody's seen, what's your default password? Oh, my default password is password. Not recommended, it's just not. Private cloud. Resides on the client's own hardware or on resources completely dedicated to the client. The people in here who have virtualization probably have this a private cloud in their building. That's what they've classified it as. It's your hardware, you run your VMs on your hardware. They've termed it private cloud. Not sure why, but they do. It's a lot more expensive because at that point it's your servers, it's your storage system, all the infrastructure that goes with it. That's all for you to take care of. Use case, customer wants to have full control over their environment. So when we talk private cloud, you could also do private cloud from a hosted provider. The problem is the costs are usually not fathomable, except the rarest of cases, say for instance, financial institutions or healthcare where they have to comply with HIPAA or whatnot, or SOX or PCI compliance. Because at that point, the hosts you're using have to be dedicated to you and only you. I can't go and, ABC widget company, move their VMs onto your hardware because that's not what you're paying for. You're paying for private stuff. So the provider has to take on the liability of having separate physical hosts for you and separate network for you. Typically, storage is not part of a private cloud insofar as I can share storage amongst hundreds or even thousands of virtual machines and only present the ones that have your VMs on it to it so that none of the other physical hosts can access it, which is considered actually a viable security strategy. Protecting the ones from other people accessing them. The hybrid cloud. This has become more common as internet speeds increase. We've got people with gigabit now, so you can actually turn around and run some of your stuff in-house. Maybe you already have an existing private cloud, and then you want to run some stuff outside on a provider's hardware. Well, That's cool. Use cases. Moving everything to the public cloud except applications that run better on local hardware. One of the things I usually think of when I think about this is anything to do with video. If we're talking about working with high-def video, it can take a gig a minute for that, or more, depending on what sort of codecs you're using. And that's all access time. If you put that out in the cloud, to have to pull that down to work on it every time, it's not going to be a good experience for you. We're talking basic files. You can have a SQL server out there with the front end out there, and good example, on-premises hardware running, it works, but running out of resources. You're going to use a new ERP or accounting system that has a certain set of requirements. And before you go and have to go and purchase more servers, maybe consider the hybrid cloud. If you do it well, you don't have to worry about it going down in case of a power outage, because typically it's going to be hosted in a data center that has UPSs, multiple generators, all the redundancy that you'd have to pay for yourself and then some. The bill's not on you. It's part of the provider's, that's their cost of operation. It's factored in, but it's not something that you have to worry about. You get to go to bed at night not thinking about what if a tree falls, takes out the power cable to my building, and then it's going to run on UPS for 20, 30 minutes, and then, will the generator kick on? Well, it's just been maintained. I've watched it happen. I've worked at places where, they just maintained the generator last week. Somebody left it to standby. Never started. They were doing maintenance on it. They tagged the equipment. It's an oversight. It happens. And perhaps you have older on-premises hardware. Maybe you're running VMware ESXi 4. Well, the most current version now is 6.5. Maybe your hardware won't support the newer versions. Well, you can go, again, buy new hardware, or run what you got for a while and slowly start moving stuff out into the cloud. Bring up a file server out there, sync your server out to that. You can still access it the same way with an MPLS or a VPN connection. The biggest thing about cloud is distance matters. Electricity moves at the speed of light, 300,000 kilometers per second. But distance equals latency. If I'm going to reach across a long distance, I'm going to feel it. Latency, it's cloud killer. In this case, if we're talking about you have something here in Michigan and we go ahead and sync out with servers, say on the West Coast, well, that's what, 1,700, 2,000 miles? It's got to make a round trip of 2,000 miles, which doesn't sound like much. It's milliseconds, best case. But we still have to hit all the various routers and things in between there, which each introduces a millisecond or two of latency. So we're talking round trip times, not including the processing time it takes to do on your virtualized stack there. And the providers typically tend to run it, if you look at their SLAs, they may not have, they'll guarantee your VM is up and running. They may hit a rough patch where the disk subsystem, the storage system, which is usually the main point of contention in most virtualized environments, if the storage subsystem can't hold it, it usually falls apart. And we're talking storage works 1,000 times slower than CPU. Physical hard drive, access time of 3 milliseconds. We're talking nanoseconds when we're talking about CPU and RAM. 70 nanoseconds is considered a lifetime in CPU or RAM. So storage is, like I said, usually where that falls apart. I've investigated a lot of people's public cloud, or private clouds rather, and a lot of times it's, they bought this, this piece of hardware, it's, purported to be this great, it moves, 300 megs a second. What's the access time? What do you mean? How fast can it get you those bits? And what happens if you run a database against it, or something where it really chews up disk in terms of I/O? Well, you're not going to have a great day with that. So latency, it's the thing that, it can affect private cloud or public cloud, especially if you go far away. So in conclusion, virtualization allows easy growth. If you want to bring up a new server or service and you have a virtualized environment, it's as simple as buying a Microsoft license, unless you have some sort of other SA agreement with Microsoft. You spin up another server. It take you less than an hour to bring up another Windows 2012 or 2016 server, get all your roles to it, IP it, and start doing the functions. We're talking hours. It takes weeks to order a server. Even if it's on the shelf, it still takes days to get it. Then you got to provision it, get it racked, cabled up. It takes time. Virtualization can save money and provide redundancy. If it's a single physical server today, if it's running, just file services, and that server goes down, it's down. Even if, unless you have something like DFS, which that technology works well, but what if the DFS isn't in the building? What if it's in some other building? Now you have to traverse whatever your internet connection is, and you're going to feel that, especially if it's larger files. Virtualization is complex. To set it up from the onset may not be terrible, but there might be things you don't necessarily see down the road, and that could affect the performance of the environment, as we talked about. I recommend everybody do this. Talk to an expert. You may have in-house people who are really up on virtualization. There's a lot of good websites out there to find good information on, but talk to another human that really knows their virtualization stuff. It's important, and your business will depend on it, because, well, if it's down or you try to make a go at it and there's a problem with it, then you have to call somebody up and hopefully get them in there quick enough to troubleshoot, diagnose, and come up with a resolution plan quickly, which in some cases may include new hardware. So, talk to an expert. Thank you. Anybody has any questions for me? Be happy to answer them. Anybody? Yeah.
When you're using, like, on your example where you put, like, you're pulling data from Michigan, from, say, Los Angeles or wherever.
Sure.
Say a simple file, just say, like, okay, we'll say an Excel spreadsheet you're pulling up.
Okay.
What's the response rate typically? Is it like a second, or is it like...
It could be less than that. There's a couple factors there. First of all, what type of circuit do you have? Do you have T1s, do you have EOC, do you have fiber? And even if people like, oh, well, I have gigabit, that doesn't mitigate latency, because your gigabit from you to your provider's network. From there on, I can't tell you where it goes. It might go through Chicago. It could bounce through Florida for all I know. It'll take a route on the internet and get to there eventually. Ideally, we want to see sub 50 millisecond, but every time we increase the size of that file, it increases the number of bits that have to go back and forth. Remember, round trip time. So it may be 50 millisecond round trip time when we ping it. That's with no data. That's with a tiny little packet. We start talking about something like that. It may take a second or two. It could take more, though. It depends on, like I said, what's on the far end. What sort of SAN are they running? Are they running a massive EMC, or are they running local storage with some SSD hybrid or something? And the load that they're incurring. So can it be a second or two? Sure. Could it be effective? Yes. You might want to look at remote desktop for something like that too. But yeah, it's usually not terrible, but like I said, it gets worse with file size. Larger file sizes will hurt because, like I said, it's round trip time. I have to keep bringing that bucket back and forth. Anything else? Yes?
When would you say it would make sense to move your private cloud VMs to
Public cloud?
To the cloud?
Well, if you got older hardware, if you're not looking to spend $8,000 to $10,000 per server, and the server's only part of it. Remember, we also have the SAN, which is, like I said, that's the gotcha. I've seen hundreds of virtualized environments, and at least half the time, they're suffering from some sort of slowdown on their storage system. They may not notice it, but it takes me under a minute to log in, get into it, pull up my data store logs. First thing I go for every time. And sure enough, you look, latency an average of over 15 milliseconds, which doesn't sound like much, and it's not, you will feel it. If you're running a remote desktop environment, you're copying files, everything gets affected. Right around that 15 millisecond mark. Virtual desktop infrastructure, VDI, it's like less than 10. Which if you think about, we talk about hard drives, 3 to 4 millisecond access time. Even with some sort of caching technology, we've burned half of our allowable time just on SAN accessing the disk. So, yeah, I mean, you can move some of it out there. I tell people at that point, look at moving it one server at a time. Get a domain controller out there. That's a pretty easy, simple one. If your domain controller goes down locally, your users could still authenticate. Because it'll look, services will be like, oh, well, I have this server over here, I can authenticate against it. Will it be the fastest? No, but at least you'll still be up while you try to diagnose what happened with the domain controller. Maybe a key expired. Happens a lot. So, yes?
Do most companies that, when you're like, if you're using like a public cloud, they're going to charge you like for every time you're getting a file or something like that, they're going to charge you a tiny little fraction, right? And are most companies doing like that, where you're paying?
For throughput, potentially. You want to look at what it is what sort of cloud you're signing up for, if they have any sort of penalty for access times, because I know, like, for instance, there's ways to store data out in, Amazon. They have their Glacier product, which they'll let you put data up there, and it'll be free. But when you have to get the data back is when they charge you. In the cases of an actual running VM, they'll usually charge you for outbound data, not inbound data. Is it much? It's usually not much. It might be a couple cents per gig or what have you. So if you're moving a lot of files out there, you probably would consider, depending on what sort of files they are, looking at like remote desktop or something. If you're concerned about pulling a lot of files back and forth, something like that, where you moved all of your processing load out there. So at that point, you're just doing remote desktop streaming, which is relatively low. You're not pulling, gigs of data back and forth. It's a good solution for that. Anybody? We good? All right. Thank you very much, and thanks for listening.